students. 50 students are there in the meeting. So we will start the meeting. Okay. रेजोनेंस वाला प्रैक्टिकल किसको किसको समझ में नहीं आया? ओके, किसको किसको समझ में आया? रेजोनेंस वाला प्रैक्टिकल किसको किसको समझ में आया? प्लीज रेज योर हैंड्स. सिर्फ एक को. Who have understood the resonance practical? Only 3 of you. 4. Please raise your hands. Those who have. Okay. 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 Now another question. Okay. Lower your hand. Now, anyone have any difficulty in the resonance practical? आपने सबने किया perform? Yes, no? Okay. Yes, Pranil, you have difficulty or what? Pranil? Hello? Pranil, do you have any difficulty? Yes, Pranil. Take it seriously, and today by means maybe today you have to upload your all the groups as well as topics. Okay, and also our presentations will be in the practical session most probably, and you have to write the dates of the presentation, else I will write at that date you have to be present for the presentation. If there is any difficulty, ask me now only. Yes. Presentation from next week, maybe you are having midterm exams. Okay, so maybe we can have presentations from coming Monday. Okay, those who have difficulty, okay, so I will, you can ask me in the practical session itself. Okay, I am expecting that you I want to check how you have implemented the circuit and how you have tackled the difficulty. Okay, one of the part or one of the slide will be difficulties encountered, so that also I will be keen to listen on it. Okay. Yes, any difficulties, anyone?
No, sir.
So please, all of you, please update your groups, okay, and topics by unit number 6 AC circuits, right? So now, I have covered this unit maybe into practical sessions, right? Yes or no? In first practical sessions, I have, as we need to do the practical, we need to understand what is phasor diagram and what is all that, how to deal with the AC circuits, right? I have told you how the resistor will act when we are. Okay, so yes, have anyone started recording? Anirudh, can you record it? You have started? Okay, great. So yes, so till now what we have seen in the practical session, we have seen that how the resistor will act when we are giving input as an AC circuit, right? How the resistor will act, how the inductor will act for AC input, how the capacitor will act for the AC input, right? resistor जो होता है उसका resistance को क्या denote करते हैं हम लोग? R, right? जो inductor होता है उसका notation क्या होता है?
Excel.
और जो capacitor है उसका XC,
XC.
right? और XC was equal to
1 upon omega C.
XL is omega L and X is 1 upon omega C. Very good, great. Now XL, what is XL? Omega L, right? What is omega? Yes. What is omega?
2 pi F.
2 pi F L, right? And X is what? 1 upon
सर दूसरा कलर यूज करो ना सर.
2 pi. Yes.
सर दूसरा कलर यूज करो सर ये थोड़ा.
Okay. दूसरा color, no problem. So your XL is equal to 2 pi FL, right? So can I say XL is directly proportional with frequency and XC is nothing but 1 upon 2 pi FC, correct? That is XC is inversely proportional with frequency. What is XL and XC? Can I say that it is resistance? Yes.
Yes sir.
Yes, sir.
Okay, so this is called as resistance of inductor and this is called as
Resistance of capacitor.
of capacitor, right? और जो रेजिस्टेंस ऑफ इंडक्टर है नहीं तो रेजिस्टेंस ऑफ कैपेसिटर है जो फ्रीक्वेंसी पे डिपेंड है, इसको बोलते हैं रिएक्टेंस. क्या बोलेंगे? रिएक्टेंस, राइट? सो एक्स जब आएगा उसको रिएक्टेंस, एंड देन देयर इज कॉल्ड एज जेड. जेड इज व्हाट? जेड इज
Impedance.
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 Impedance मतलब भी resistance. So let us say that we call Z is equal to R plus J into XL minus XC, right? Why J component is there? Because we are drawing the phasor diagram and we are using the Argand's diagram because we are dealing with the magnitude and angle, right? So this part is your reactive, this part is your resistive, and total resistance of the circuit is called as impedance of the circuit. ये आपको clear है? Yes, no?
Yes, sir.
Okay, great. So, today, as we have spent maybe more than 3 or 4 hours on this basics. So today I will just go through the PPT and I will show you that what is your unit number six AC circuits, which we have already covered, right? So yes, I will just go on to the presentation, and then in I will just go and I will just correlated that what we have seen and what is this what are all the PPTs, right? At any point in the presentation, if you have any difficulty, you can stop me. Okay. Also, as a class teacher, there is an announcement that feedback, uh, feedback for your this semester is open, so kindly give the feedbacks, okay, on the ERP. So everybody is accessing the ERP? Yes, no?
Yes, sir.
Yes, sir.
Yes.
Great. So that was one announcement from my side. Yes. So this is unit number 6, AC circuits. Okay. AC means what? Alternating current, right? Okay. So these are the reference books. Okay. You can use any of the reference book. For your first year, only basic concepts are expected. You should learn basic concepts, right? So what topics we will be covering? Generation of alternating EMF. Do you remember? We have seen something called as generation of AC circuit. Yes, no? Generation of AC signal.
Yes, sir.
Yes, yes. So we have seen a very nice video on that. So what? How do we generate that? Please.
By using AC generator, sir.
Yes. What are the components of AC generator?
It works on the principle of Faraday's law of electromagnetic induction, sir.
Great, great. Means what? There will be
And
the magnetic field and there will be rotor. Okay.
yes, sir.
The rotor will rotate as there will be change in the flux linkage. What will happen? EMF will get induced. Okay, and like that we can generate EMF, right? After that we have seen that what is the equation, how we can represent this, right? How we can represent this. जैसे देखिए how we can represent this. Yes, by a sine
Phasor
wave,
diagram.
by a sine wave, right? And then sine wave, after that, if we are having another sine wave, we can compare these two sine waves by using the phasor diagram, right? Yes, no?
Yes, sir.
Okay. So you know why that sine wave came in the picture? Because once okay, who have invented this? Science, basic science. किसने invent किया है सब?
Don't know, sir.
Okay. Have you heard Tesla?
Yes, sir.
Yes.
Yes, sir.
So
Nikola Tesla.
he have invented electricity, right? So there is a story that one day he was sitting at the side of let us say sea, right, seashore, and then he was watching that okay, a cycle is coming from a road and passing to it. Okay, so what he have done, he have concentrated, let us say that this is a cycle, right? And okay, I'm not very good in drawing, but yes, this is your cycle, and yes. So what happened? One day he just he have concentrated that yes, there are spokes of the cycle, and then say there is a through which you can get air, right? So he have concentrating on this as the cycle was moving, right? There was circular motion, right? There was circular motion, but there was a sine wave, right? If you track this valve, right, this will first increase and after that decrease, and again it will increase, again it will decrease, right? So can I say there is a semicircle, right, which will make one part of the sine wave and another semicircle which will make another part of the sine wave? Yes, no?
Yes, sir.
Yes, sir.
So yeah, so this is how, you know, he have understood that yes, we can represent this waveform by a sine wave. So we have seen that yes, we can represent it by sine wave, right? So we will see its waveform, and then, you know, if there are two diagrams, we can see its phasor diagram. Okay, after that, you know, what is the impedance, admittance, and power triangle? Okay, so impedance and admittance we know. Okay, impedance we know. What is admittance? Okay, resistance we know. What is ulta of resistance? Conductance, right? So like that, impedance ka ulta kaun hoga? So that is your admittance, right? Okay, and then we will see power triangle. So this is the part on which we will be concentrating on, because we have not covered it in the practical session, right? And after that we will see what is RL, RC, RLC circuit, right? So this we have seen properly, and then we have completed series resonance also, right? So we will try to go through that series resonance, and then similar to the series circuits, there are parallel circuits, so we can see that parallel circuits also. Okay, so first of all, alternating system. What is alternating system, right? What is alternating system? We can say yes, alternating current. Or what is alternating system? The magnitude changes with respect to the time. That is your alternating system, right? Yes, no?
Yes, sir.
Yes.
So here in each and everything, right, there is continuous signal. The magnitudes are changing with respect to time. Hence, this is your alternating system, right? Or in a simple manner, if you observe your x-axis, right, the signals are alternating. They are flipping between about the x-axis, right? So you can say this has alternating waveform, right? Basically, we call alternating signal as yes, a varying signal, right? Now, how we can generate the alternating EMF? So yes, as we have seen, there is a permanent magnets, north pole and south pole of the magnet, and there is a conductor. Let us say there is a coil, and this coil is rotating. Okay, so what will happen? As it will rotate, it will cut the flux lines, right? And as the flux lines will get cut, according to the Faraday's law of electromagnetic induction, what will happen? You will get the current will flow in this circuit, and you will get the waveform, right, across the resistor. Okay, so this is the brief explanation which we have seen. And yes, now you know what is the induced EMF. So it is the equation of the induced EMF is given as E is equal to 2 into BLU sine theta, right? What is this? You know, so we can have the total magnitude, right? What is EM? EM is nothing but the maximum value of the induced EMF. That is equal to 2 into BLU, right? Now, why BLU? Because whenever the angle is 90 degree, at that time the E will be equal to sine theta will be equal to 1, and you will get the maximum value of EMF, induced EMF. That is your E, right? Now, you know what?
Sir, excuse me, sir.
Yes.
What is BLU, sir?
Yes, BLU. I am coming to that. Yes, anyone, can you tell me what is BLU? What is B?
So magnetic field.
Yeah, magnetic field. But how we can measure? That is your magnetic flux, right?
Yes, sir.
Okay. L is what? Length.
Length of the
Length.
rod.
Length. Okay. B is what? Breadth. So can you find the
Yes.
area? Yes.
Yes, sir.
Yes,
Okay.
sir.
And what is U? What is U? It is rotating, right? So
Yes, sir.
yes. So at what velocity is rotating?
U,
So
velocity.
yeah. So U is nothing but meters per second. That is your velocity. And if you want to find, that is your pi bn. Why pi bn? N is number of turns, right? Okay. So finally, what is your important formula is EM is equal to 2 pi B into A into N volts. So this is the maximum. Yes, N is nothing but the speed of the rotation, right, in revolutions per minute in RPM. Okay. So EM is given as 2 pi B A into N volts. Yes, any problem in this?
No, sir.
Okay. So we are concentrating not on this formula. We are concentrating on this formula, that is E, induced EMF or instantaneous value of EMF generated is equal to EM into sine theta, that is 2 pi BAN into capital N into sine theta, right? Where capital N is nothing but number of turns. We will see further. Okay. Now, induced value of EMF generated, right? That is provided in the previous formula, and yes, that EMF, we can, if we can represent it in the form of waveforms, right, then this is the sine wave, where EM is nothing but maximum induced EMF in positive direction, also in negative direction it is maximum induced EMF. So this EMF is also called as peak voltage, right? This EMF is also called as peak voltage. And one circle rotation, right? 0, 90 degrees, then 180 degrees, then 270 degrees, and 360 degrees, right? So this is one cycle, right? When it will cover one rotation, right, it is called as one cycle. Yes, no?
Yes, sir.
Okay.
Yes, sir.
So there are some terminologies which we will be quickly revising. What is waveform? Variation of quantity of voltage or current, right, with respect to time, right? So that graph is called as the waveform, right? Cycle is what quantity of the graph is repeating itself, right, continuously. That is your one cycle. Okay. So here one is from 0 to pi, 2 pi, it is continuously that cycle is rotating, so we call it as one cycle. Then what is the period? How much time, or what, how much, you can say, if we can calculate in angles, right, what part is rotating. Okay. So what is the time period? Time period is nothing but the time taken from the, for the waveform for completing from 0 to 2 pi, correct? So the time taken for completing one cycle, that is called as your time period of the waveform. What is instantaneous value? किसी भी टाइम पे अगर हमें कुछ, किसी भी इंस्टेंट पे, if you want to find the value, that is called as your instantaneous value. Peak value is maximum instantaneous value which occurs either in positive or negative direction, that is your peak value. What is peak to peak value? We need to calculate the distance between positive peak and negative peak, right? So positive side में कितना peak value है EM, negative side में कितना peak value है EM. So EM plus EM कितना हो गया? Peak to peak value 2 times EM, right? So that is your peak value. What is peak amplitude? Peak amplitude is nothing but is the amplitude at the peak point, that is your peak amplitude, that is EM. And frequency is nothing but we all know it is your inversely proportional to time, so it is reciprocal of time period, right? So these are the waveforms, and here you can understand. So all these things we have seen. Yes, no?
Yes, sir.
Sir.
Yes. Now a coil of 100 tons is rotated. 100 tons means what is given?
Capital M.
Capital N is given, right? Is rotated at 1500 rpm. What is 1500 rpm? Right? So can we find the frequency revolutions per minute? Right? So 1 second में कितने revolutions होंगे? Having the
1500 by
having
60.
yes, 1500 by 60, having the uniform density of 0.05 Tesla. What is 0.05 Tesla? B, capital
B.
B, right? Yes, yes. The mean area per turn is 40 centimeter square. What is 40 centimeter square? Area,
Area.
right? So 40 centimeter square, we need to convert it into meter square. So it will be 0.004 meter square, right? Calculate. Can we calculate the frequency? Yes. Once we get the frequency, can we calculate the time period? Reciprocal of frequency is the time period, right? Then maximum value of generated EMF. Yes. Formula is 2 pi capital B into A, correct? Into F into N. What is N? 100. Yes, no?
Yes, sir.
Yes, sir.
And the value generated of EMF when the coil has rotated through 30 degrees from the position means what is given, what they want, instantaneous value. So we have the formula E is equal to pi into, yes, sine theta. So it is 1.57 volts. Yes, no? EM
Yes,
sine
sir.
theta. em
Yes,
sin
sir.
theta होता है ना, em sin theta. why em sin theta? because instantaneous value em sin theta, because अभी हमने देखा है, because we can represent the waveform by using sine wave, that's why we are using the sine function. Yes. Okay.
Yes, sir.
Yes.
Now next part is average and RMS value. Now what is average value? Average value is nothing but, okay, how to find the average under of this curve? So we can say area under this curve is called as average value, right? So how to find the area under the curve? By using the definite integration. Application of definite integration is to find the area under the curve, right? Now if you want to find the area under the curve, right, we need to take the limits from 0 to pi, correct? And what is this? Let us suppose this current is, this is a current waveform, so this is I is equal to Im into sine omega, sine of theta with respect to d theta. Is it correct? Yes.
Yes, sir.
जैसे जैसे हमने वोल्टेज देखा ना, वोल्टेज का फॉर्मूला क्या था? स्मॉल v इज इक्वल टू कैपिटल ई एम इंटू साइन ऑफ थीटा. सो सिमिलरली if we divide this by r, if we divide this by r, e by capital R is small I, em by capital R is im. So can I write, can I say that you're in the circuit, if you are applying voltage, that is alternating voltage, then current will flow in the circuit, that current will also be a alternating quantity, correct?
Yes, sir.
So
Yes,
for
sir.
explaining that only I am taking the current here, and we can find the area enclosed under this curve by using the definite integration, and that comes out to be 2 into Im. So whatever quantity is this, right? Now we can take the average of this, right? Why average? Because from what to what we are considering the curve, so from 0 to pi. So if I want the average, I will just divide it by pi, correct? Yes. So if I divided this by pi, I will get the average value. So average value is 2 I am coming from here, and pi because we are considering this part of the waveform. Yes, no?
Yes, sir.
Yes, sir.
And RMS value is what? RMS value is, RMS value is always given by Im by root 2. Okay, there is a derivation, root mean square. आप mean है उसका root ले लीजिए, right? Means you just take the root of this value and then, sorry, the root of this value and square it and then solve the integration, you will get this value. Okay, so I will logically explain you what is the RMS value and what is average value, right? Okay, RMS value मतलब क्या है? There is one resistance, right? There is one resistance. Okay, there is a circuit, there is resistance, and there I am applying the DC voltage, let us say 5 volts. Okay, and let us say this is 1 kilo ohms. Okay, so how much power it requires to heat the resistance or to dissipate 1 watt of power? Okay, getting in DC. Okay, let us suppose there it it needs some power to dissipate, it needs some current to dissipate 1 watt of power in this resistor. Now what I'm doing, I'm just replacing this DC circuit, I'm just replacing the DC circuit with AC circuit. So what will happen? Again current will flow. Yes, no? Now I want to find the value of current which will dissipate same 1 watt of power. Okay, and that value of current is called as RMS value of current. समझ में आ रहा है आपको? Yes.
Yes,
Yes.
sir.
So, okay, अगर नहीं समझ में आया, so just keep in mind I is equal to Im by root 2, that is RMS value of the current. Okay. Yes. So so similarly there is one more example, you can just see this wave example. Okay, now representation of alternating quantity by a phasor diagram, right? Now phasor, why phasor? Because yes, we can deal very good with this waveform with angles, right, as it is a sine function. Okay, sine omega is 2 pi f, and if there are two quantities, one is current and another is voltage, and both are not starting at the same point, right? So how we can say that there is some difference, right? There is some difference. On x-axis I am taking your radians, so there is some difference phi. So what is the difference between these two quantities? If the frequency of two quantities is same, then there is angle difference between the two quantities. Alternating current और voltage में क्या difference रहेगा? Angle का difference रहेगा. Angle difference, that is called as your phase difference, right? So let us suppose that you are saying that yes, I is equal to I am sin omega t, blue वाला जो है वो so black वाला जो waveform है, okay, I will just extend it, okay, I will just extend it with red color. So वो कहीं तो भी यहाँ पर चालू हो रहा है, right? पहले चालू हो रहा है, करंट से पहले वोल्टेज चालू हो रहा है ना? Yes. So that's
Yes,
why,
sir.
yes, that's why we can call it as voltage is leading current in this diagram, because voltage का diagram पहले हो रहा है, right? So phi plus phi, right? So this instantaneous volt value we can give with Vm sine theta plus phi, where theta is called as phase difference between the alternating quantity. Any problem in this?
No, sir.
No, sir.
So now simple thing what we have covered, I will just cover it. Okay, so alternating current in resistive circuit. So here it is R and we are passing a alternating current. So yes, we know that this I is equal to V by R, Ohm's law. And then we know that voltage and current in resistor are in phase, correct? Yes or no?
Yes, sir. They are in same
Yes,
Yes,
sir.
phase.
sir.
They are in phase, so that's why both the waveforms are starting and ending at the same point. Maybe there is some amplitude difference, but yes, दोनों कैसे phase में रहते हैं, right? And hence we can represent the phasor diagram, which I have already shown you. Phasor diagram, voltage and current both are in phase, correct? Yes, no?
Yes, sir.
Any
Yes,
Yes,
sir.
problem?
sir. No, sir.
Okay, now
No.
when inductor is connected, okay, to okay, fast हो रहा है थोड़ा आपको, or is it
No, sir.
good? Okay, those who consider that okay, you are not getting something or what fast teaching some, I request you to go back to which I have already given for, right? So you will better understand there, because two times same concepts I have explaining, and this is the third time. So yes, let us say that in inductor, what happens, in inductor, let us say I am sine omega t, so E is nothing but L di by dt. And if you differentiate, right, what happens if you compare, if you convert this E in terms of sine, then it is 2 pi f plus pi by t. Plus pi by t means what? Here if I extend this voltage waveform, okay, if I extend this voltage waveform, then there is a phase difference of pi by 2, right, or 90 degrees. Okay, so here I can say voltage is leading current by how much degrees? 90 degrees,
90-degree.
right?
90
So
degree.
yes, inductor, voltage in the inductor is L di by dt, that we have seen in the 12th class. And here I can say inductor will store the voltage, store the energy in the form of current. Inductor will store the energy in the form of current. And yes, this is the relation between current and voltage in the inductor. We can say in the inductor, voltage leads current by 90 degrees. And if we try to draw the phasor diagram of it, then it is, if I is there, then voltage will lead means what? In the anti-clockwise direction, voltage will be there. So this is the phasor diagram for inductive circuit, correct? Yes, no?
Yes, sir.
Yes, sir.
Sir.
Okay, similarly I have told you that yes, what is xl, what is xl, what is xl? 2 pi fl. So can I say xl is directly proportional to frequency? So as the frequency will increase, the inductive resistance will increase, correct? Right? So this is straight line passing through origin. Yes, no? Because this is of the
Yes.
form y is equal to mx. Yes?
Yes, sir.
Yes, sir.
Yes.
Great. So in inductor, you know, the inductor will increase, inductance will increase, resistance will increase. So what will happen to the current? Current will decrease. समझ में आ रहा है? So current decrease हो रहा है, मतलब current lag हो रहा है, current store हो रहा है, voltage आगे जा रहा है circuit में. Getting? So this is another logical explanation from my. Now comes resistor and inductor in series. So when we connect resistor and inductor in series, right, we can call that, yes, we can say that, yes, if this is I, in the same direction, voltage in resistor will be in phase with the current in the circuit, correct? And voltage in the inductor will be 90 degree out of phase with the circuit. So if we want to find, सिर्फ मैंने सिखाते वक्त ऐसा बोला था, this is VR, this is your VL, and then we can apply diagonal law of vector addition and we can get the value of total applied voltage V. Here they have applied the triangular law. Any problem in this?
No, sir.
No, sir.
What is phi? What is phi?
Phase
Phi is the
difference.
phase difference
Phase.
between what? Final voltage, total voltage and total current. Getting?
Yes, sir.
Yes, sir.
So as this is an inductive circuit, because inductor is there, your voltage will lead current, but not by 90 degrees, but by some angle phi. Getting?
Yes, sir.
Yes,
And
sir.
what is tan phi? What is tan phi? XL upon R, right? Tan
Yes,
phi
sir.
XL upon R. And what is total voltage? It is nothing but the phasor addition. Phasor addition matlab kya? VR square plus VL square ka root. So if you want to find the voltage, this is the formula. If you want to find the total impedance of the circuit, again we need to do the vector addition of resistance offered by the resistor plus resistance offered by the inductor. Correct? ये formula सब हो गए थे हमारे? Yes.
Yes, sir.
Yes, sir.
Now very simple quantity, right? And this we have seen phi is tan inverse of VL by VR, or phi is equal to tan inverse of XL by R, right? Now a resistance of 7 ohms, what is given? R is given, right? Is connected in series with pure inductor of 38.1 millihenry. What is given?
XL.
XL नहीं, L is given, right? XL का
L.
unit ohms में रहेगा, right?
Yes, sir. Yes, sir.
Connected to 100 volts, right? 100 volts means what? Total voltage is given, and this frequency is given. So can you find XL? 2 pi FL. F we know, L we know, correct? Yes, no?
Yes, sir.
Yes, sir.
Yes, sir.
So we know R, we know XL. Can we find impedance? Z, root of R square plus XL square. So total impedance of the circuit मुझे पता चल गया, right? ओके मुझे टोटल वोल्टेज पता है, अप्लाइड टोटल इंपेडेंस पता है, तो करंट पता चलेगा हमें? Yes, of course we can
Yes, sir.
voltage by resistance, so that is the current in the circuit. And if you want to find the value of phi, so we know XL, we know R, so can we get the value of phi? Yes, of course we can get it. Yes or no?
Yes, sir.
Yes, sir.
Great. So any problem in this?
No, sir.
No.
No,
No,
sir.
sir.
So I expect that one problem you will see at home. Now comes the capacitance circuit, right? So in capacitance circuit, again we know what? There is a voltage Vm sin omega t, and current in the capacitor is given by C dV by dt. Is it correct? So if you simplify, if you take the derivative of sine, you can convert it into cos. It is cos, and cos we can convert it into sine by adding plus 90 degrees, right? So here if we compare this current and voltage, we get that current in the inductor, sorry, current in the capacitor leads voltage by 90 degrees, isn't it?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Now, now, now what? Next is Xc is 1 upon 2 pi of C. So Xc is inversely proportional with the frequency. So देखिए frequency जैसा बढ़ेगा वैसे क्या होगा, उसका रेजिस्टेंस कम होगा मतलब क्या, करंट आपका आगे जाएगा. Yes, capacitor always stores the energy in the form of voltage, similar to RL circuit. Yes, no?
Yes, sir.
Yes, sir.
Okay. Now if frequency is given, right? If what is this? Capacitance is given, voltage is given, frequency is given. Can you find capacitive reactance? X is 1 upon 2 pi of C. And can you find current? Current is nothing but voltage divided by capacitance, isn't it?
Yes, sir.
Yes, sir.
Now R and C in circuit. So again same analogy. What will happen? Just VR is there and VC. If this is I, what will happen? The voltage will be in the downward direction. Why? Because voltage lags current by 90 degrees. And if you find the voltage by using phasor addition, this is the voltage. Correct?
Yes,
Yes.
sir.
Yes, sir.
Okay. Okay. Now what? Yes, now. What you can say?
10,
Hello?
5.
Hello? Yeah.
Yes, sir.
Where were we?
RC series.
Yeah. So in RC series, we can say if we want to find the total impedance R square root of R square plus XC square, right? Voltage also you can find. So let us say that, you know, again we can have a problem. This is what capacitor C. This is current, right? Total I in the circuit. Alternating voltage is applied across it. What is alternating voltage? 230 volts. That is total voltage is given. Can we calculate the frequency? Can we calculate the frequency?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
What is XC? Capacitor. What is voltage across capacitor is VC, right? VC is what? XC into I,
I.
correct? Sorry, I into R, right? Yes, I into XC. Okay. So XC is what? VC divided by I. So you can get 230 ohms XC. So once we get XC, we can use the formula XC is equal to 1 upon 2 pi FC. So F is equal to 1 upon 2 C into XC and you can get the frequency. Yes.
Yes, sir.
And then you can find resistance and all the components, right? So any problem in this?
No, sir.
Now let us go to RLC series circuit, right? And we will concentrate on resonance part, right? So in RLC series circuit, what happens? We have three cases, right? We have three cases. So in RLC series circuit, what will happen? R, L and C will be in the series, okay? So what is the total impedance? What is total impedance of the circuit? It will be root of Z. Z will be root of
X will minus XC whole square plus R
yes.
square.
R, sorry, R square. Z will be root of R square plus XL
XL minus
XC
XC का whole square.
square, right? XC minus XL लीजिए, XL minus XC लीजिए, whatever it is, you can get this R, right? Yes. And depending on, there are three cases, right? But we in resonance we have we have seen all the three cases. And yes, here tan phi or phi is what? Tan inverse of reactive part. What is reactive part? XL minus XC divided by resistive part R, correct? So tan phi we get XL minus XC divided by R. I have given a complete derivation of it. Yes, do you remember this thing? Yes or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, great. And then you know, this is I, and then we if we know V, we can find I if we know Z, right? By using Ohm's law. Okay. So this is the thing in alternating current in series RLC circuit. Any problem in this?
No, sir.
Okay.
No, sir.
So I think that we will stop here and then we can continue parallel circuits in the next lecture. If you have any difficulty, we can discuss in next lecture. Anirudh, please stop recording. Yes, Anirudh. Hello. Okay. So let me take the attendance. Can you see my screen?
Yes, sir.
Yes.